Okay, looks like we're right here at the right time here. Looks like we've got quite a few of you guys showed up, which is pretty exciting. And as always, this is just time for you guys to ask whatever questions you have. I don't have anything prepared.
Homework,
Okay.
please. What the heck?
Which one?
The one that we're supposed to be doing right now.
Number 4?
Yes, sir.
Okay. Before we jump into that, did anybody have questions on the exam we just took or anything that'll be quicker to answer? I think for the most part, everybody did pretty well because it was open notes. But if you got questions, let me know. So how far have you made it on this assignment?
Not that far.
Yeah, I was about to say, I read it a few times and I watched the video 3 or 4 times
Okay.
slowly. And then I was like, right. I know that we kind of touched on this whenever we were doing the homework from, I think, 2, whenever we were replacing stuff with the dummy variables. But I was like, man, I don't remember how we were doing that.
Okay.
That's one of those one. If you've only done it once or twice, it doesn't really stick that well.
Yeah. Yeah. So the last times we went through the homework, I did all of the answers. I'm not sure how I feel about that because then people who are turning in late were able just to watch the videos and copy and do just fine. And so,
Right.
I think I'm gonna do something a little different. And I'll do the first 2 with everybody as a class, and that'll leave you guys the last little bit. But we can discuss and think about it. But I don't want to just straight out give the answers like I have been doing. So hopefully doing these first couple will get you on the right track at least, and then we'll see from there how you guys are feeling. Does that seem like a plan?
Yeah.
Okay.
Because I mean, like even B, the regression part should just be just like the one we just did, right?
Yeah, exactly.
And then the variables which are significant, it's kind of just talking it out and showing it.
Yeah. Okay, so so the main point of assignment 4 is how to clean up data. So you're going to get some data that may not be perfect. No data is really going to be perfect. There's going to be lots of issues with it. And so before you can even do the analysis on the data, in the real world, you'll have to do some of these sorts of steps that we're talking about here in this module. And that's the point of this assignment. So let me... There we go. All right. So we got this MEPS data. This is real data. This is, I think, Minnesota or Minneapolis puts this out. So there's a lot of columns, a lot of data. And we have the key here that will describe more about what that stuff is. So we'll get that open too. I hope. It's frozen. We'll give it a second. That's frustrating. Okay. Yeah. Okay. Here we go. Okay, so we got the data, we got the key. Yeah, Minnesota, that's right. Okay, so here's the question. So let's see. Check to see if there's any missing data or outliers in these specific variables. So what do we mean by missing data or outliers? So we got to know what we're looking for, right? So can somebody define what that would be? How would we know if something's missing or an outlier?
Well, it says it on the key. It says like if something's unknown or missing, there's a certain number that's inputted.
Okay, so let's see. So like this race, for example. Oh, so you're talking about 900 is it unknown?
Yeah,
Okay.
wouldn't it be considered missing?
Sure, that's a good, okay. That would make sense. And then
Or maybe 0.
want to see if these other ones do. Yeah, so same for that. Trying to see if there's an unknown here. I'm not sure what NIU means. Maybe that's their unknown. Does it say? Oh no, here we go. Sorry, I didn't scroll. So we got a bunch of unknowns. Yeah. So maybe that's a good strategy for finding the unknowns. What was the other one? Outliers or missing data. I mean, so unknown's different, right? It's just saying we asked this person a question and either they didn't know the answer or they skipped it, maybe. But how do you know if we're missing data?
There seems to be a lot of zeros in there. So maybe.
Let's see. So which column are you thinking about? Like I see a 0 here.
I'm looking at education right now.
Education, okay. Okay, so like here on line 24, you got a 0. Let's go look at the key, make sure a 0 is not valid. No. And my computer is just not liking me. There we go. Okay. Yeah, so 0 is whatever NIU means. Okay. Okay. Yeah, so maybe that's the case. So if there's data missing, so if instead of a 0, if it was empty, obviously that would be an example of missing data. Sorry. And then outliers. What are we defining as outliers? Some of these, I mean, some of this is just purely coded data, right? There's no. Let me see here. Okay, no. So the coded data, I don't think is going to be really an issue. I think it's going to come down more to these whole numbers, these continuous variables, where we're talking about expenditure totals, and these are in dollars. And you see, there's a pretty big range, right? Like this costs somebody 0. Is that a legitimate thing? Is a procedure going to cost somebody $0? Maybe. That might be considered a missing data piece. Or outliers. So outliers are going to be things that just don't make a lot of sense. And those are easy on these coded data, right? Because we know on education, for example, we're expecting a number basically between just these are the exact numbers, right? So if we see something like we got 201 through 204, those are all legit. If we see something that says 207, I mean, we have data, it's not missing, it's just inaccurate, right? We don't know what a 207 would mean for education, right? So that's the kind of data that we're gonna have to clean up and decide what to do with it. Do we delete that whole row because it's tainted? Someone put in a wrong value, or if someone put in like 1,000, right? We don't know what that stuff means. So those are a little bit more, clear cut, right? We just look for the values that are permitted. But these other ones here, these are dollars, these are continual variables, and they could be anything. And we got to figure out, how do we know if any of this data is going to be an outlier or doesn't make sense? Because we see the 0 here, we might be a little suspicious about it, but when we scroll down, we see a lot of zeros, right? So it's probably a common response that people are giving. Either might mean they didn't do the procedure, or maybe they have insurance and it actually did cost them zero out of pocket. So maybe that's okay. So we might be looking for like negative dollars here because a negative wouldn't make sense. We'd also want to look for values that are like astronomically large compared to everybody else. So for example, like we're seeing averages here from like, I don't know, $100 to like, this one's a 35,000. That's a pretty huge range. Is this 35,000 a typo? Does it a real number? So we're looking for things like that. And those are a little bit harder to nail down. So some of the things we could do, there's even a 60,000. So some of the things you can do is if this expense total column is an aggregate of maybe like some of these columns, like if we have to add up these 4 columns and that should equal this column, that's a check we could do, right? So we could go find this big number, add up all the smaller numbers and see if all the smaller numbers do add up to the big number and just do a validation check that way and say, yeah, this actually is the right number. There's not something that was like fat fingered or mistyped. And that's one thing we could do. The other thing we can do, if we do find a lot of or not a lot of outliers, if we see a couple of massive numbers, we could assume that something weird was going on there, like the 60,000. Like, no, I'd have to look at all the data, but we could assume that there's something really weird going on here, perhaps. And so maybe we just want to exclude some of this data so it doesn't mess up what we're going to be doing with the data. Because maybe all we care for our analysis is we just want to see what our average is, what's the common person doing. And we may want to get rid of some of these really extreme numbers. We'd have to, make note of that in whatever work we're doing, talk about the rules we followed. And likewise, we might want to get rid of some of these zeros because if they're not paying any money, we don't really care about this person. We only care about people who are actually having to fork over money to do, procedures or something, right? So we might want to say, we've excluded all the people with $0 and all the people that were in the, whatever, I don't know, top 5% outliers to get all the high and low out of there. So it's kind of what we're looking for. And there's not necessarily going to be a right or wrong answer. And that's some of the issue with statistics. And I hope that some of this is kind of what you're starting to understand is you can make the data work any way you want. You can make it say whatever, sort of biases you have. You could include all this number and get an average that's not accurate because again, we have these extreme numbers in here. And so you just have to, put like asterisks with your work and say, we had all this data, somebody else might come up with a different result because we did this, we excluded this, we did that, we converted these or whatever. Because 2 people with the same data are not necessarily going to come up with the same results. And so you just got to be able to justify and reason why you're doing what you're doing. And you might have a special like use case that other people don't have. And so we're just trying to clean up the data. And I feel like there was another one that we were looking at. I was trying to see if we have any binary data, just ones or zeros. Don't see any of that. No. So I was looking, sometimes you might have string data like text. And if you have that, you can't work with text data mathematically, right? You can't analyze what the word male and female means. You have to convert string text into some sort of numbers that make sense, like a 1 or a 0, which we kind of did in some of the past assignments. So all of that work is what goes into cleaning up the data. And so I was just looking to see if there's any of that here. Okay, so let's go back and actually do something here. Okay, so we're going to see if there's any missing or outliers. And let's just look at, we were talking about education, so we'll do that first. I feel like I just had that. Here we go. Okay, so for education, yep. Okay, so these are the valid ones. So we could do a couple of things. So let's column E. How many rows do we got here? A couple thousand, okay. 1,000, okay. Okay, so for column E for education, what would one of you guys or one of you people do to make sure all of these numbers are valid? Does anybody have a strategy for what we could do? Because like I said, what if there's a 207 in here somewhere and we don't have a number 207? We want to make sure that just the valid numbers are in here. What would you guys do to look for that? One of these codes here. Somebody have any thoughts? Okay. There's a few things we can do. We can do min and max, which are just going to give us the whole range. Or sorry. Probably 2. Okay, so here's the minimum. So we do have zeros. And then just see what the maximum is. Oops. This is only mildly useful, right? So we can see, oh, there's a 0 and a 999. We can go look and see, yeah, there's a 0 on our list and there's a 999. So that's only mildly useful, not very helpful at all, really. There's a different thing we can do here. If you go to, oh my God, so there's like, 50 different ways we could do this. We could insert a column over here. We could write out some of that if logic, right, or the count logic that we did in the past assignments and look for each specific code and aggregate all those, and it would have a 1 or a 0 if all the codes are there or possible. Or we could break it out. We could have, like this column F could say, be a 1 or 0 if you're code 0, be a 1 or 0 if you're code 302, be a 1 or 0 if you're code 301. So we could do that. It's going to add like 30 columns just for education. It's a legitimate way to do it. And depending on what you're trying to do, it might be the valid way. But a quicker way, just for viewing what we're trying to do, we can go over here to data. It gives us a few options here to work with some data. I think data validation is the one I'm thinking of right here. So we can look at this whole column. Was it? We just got whole numbers. Let's see. We could do this. If we go back over here, circle any of the invalid data. So we can scroll up and see. We're looking for red circles. Here, let me just show you an example really quick. I'll put in a bad number. You got to actually highlight the whole column. Let's do that again. Data validation. That should work. So much. So there. Okay, so let's go see. So we want to look for, oh, we could do a list. So whole number between 0 and 999. Dang it, why isn't that? And then we want to circle. Oh, we can only do it 255. Oof. That's what's going on. It's too much data for it to handle. So I was just using this the other day. So we could do it in, so there we go. They're way up here. There was just too much data for it. So you can see all these red ones. I put in a bad rule and it'll go through and highlight for you stuff that doesn't meet the criteria. So you'd have to do it in blocks of 255, which was what it was complaining about. So that's a kind of a quick way. Let me. Maybe down to 255 here. A little tedious. Okay, let's change our rules. Data validation between that 999. That's fine. So we can just look at this first 255 and see that all the numbers are between 0 and 999. That's the next set right there. So that's one way we could just highlight the data. It's not really dealing with it, but it lets us know we should look at it. The other ways you'd want to maybe make a list of stuff. I haven't done this yet, so I don't know if it's going to work, but you can go look at a list of the valid choices. Let me go copy that and see. I haven't actually tried this. Well, I'll see if it works. Let's put that on a new tab. Yep. Okay. Data validation. List. And our source is that. Yes, I know. Okay, and then just make sure it's going to circle anybody. Okay. So now it's looking at the actual proper list, and it would highlight anybody who's not one of those exact specific things, which you can see in the cells I've selected that none of those are invalid. And then likewise, we would have to do that in 255 increment chunks. Same thing. List. Source. I know. Make sure it's going to circle. Okay. And so we could do that. And again, that's just going to highlight the issue. It's not going to solve our issue for us. So all of those that you selected are legit. They're all valid. So that's one of the things we can do. Another thing we can do is just do counts, right? We can go say how many. Go to the bottom and do this. There we go. We could say how many of these are codes, I don't know, 101's a choice, and then go do a count. How many are 102? Go do a choice. How many are 103? And just go count all of those. And that would do something a little bit different, right? That would tell us, oh, there's 19 of those. There's 100 and whatever of those, and there's 0 of these. And that might mean something to us, right? We can say, oh, our data doesn't have any of this data. That might mean something on its own right there. So that could give us some insight into our data. It might either need to be cleaned up, figure out why there isn't that, or we can report that, right? If we're writing a report or doing some sort of paper, we can say, oh, and none of our respondents were whatever and whatever, whatever. So that kind of stuff might be interesting to know. And so you can see there's like 15 different ways, or at least 3 different ways we've talked about that we could solve this sort of issue, or at least identify this issue. And the question is, what do you do when you actually find this data, right? So if we find out that, oh, there's no 103, there's not really anything to do with the data. But if we find out something like, what is it, there's 1,000 rows, we could be like, oh, there's 991 are that. And then we're like, why is everybody here? That's a different issue, right? Why is all the education just this one thing? Might have to do with where we grabbed the data, right? We might have been outside of some high school cafeteria surveying students. And of course, everybody we survey is going to be a high school student. And that's the kind of stuff we're seeing with the data. And that's the kind of stuff that's going to be insights, right? When you're reporting data and the quality and validity of your data. So those are a couple other things. Sorry, hang on. And then another thing we can do, we can select all of our data. We have over here, remove duplicates, which is interesting. You can pick the columns that you care about. It's going to select all of them by default. And it's going to go see, is there any rows that are 100% identical? And right there, we have 3 rows out of our 1,007 that are duplicates. We'd have to go figure out what those 3 rows are, and then go see if they are legitimate, right? Why do we need to delete those rows? Because we typically aren't going to have 100% duplicates because we're including things like costs and price, and almost nobody's going to have the exact same cost and price for everything that they're doing. So we'd have to do a little bit more research and figure out what are the 3 rows that are duplicated, and then decide, do we want to delete those? And again, if we delete those, we have to make note about it in whatever question we're answering or paper we're writing. Okay, so the question is, sorry, it's kind of blabbering here. Check to see if there's any missing data or outliers. Okay. So for the outliers, I would, again, I just showed you 3 different ways. I like the circle way, particularly like this, because it's nice and easy. I haven't gone through all of it yet, but that would give us outliers, right? If there's anything red circled when we're following the list, then that's an outlier, right? It's a number that shouldn't be there. And so you can make note of that. And then missing data, you have to make your own definition. Someone is suggesting a 0 might be missing data, but 0 is in our list. So I don't know if I would count that as missing data. Might be something more like you have just actually missing data, right? So instead of saying a 0, it's just blank. That might be a missing data idea. So it's going to be up to you to define what it means to be missing. So let's just finish this out, right? Let's finish education. I don't know, just select a bunch, do the validation, go use our list. Oops. I know. So all of this data is fine. I actually don't know what the answer to this is. I haven't done this homework yet, as you can tell. So I'll be curious to see if we have any. Nothing. Keep doing that. It's weird that it caps us at 255. I've never noticed that before. Okay, this should be the last one here. Data validation, list, source. You can just make sure that's turned on. I'm pretty sure it is. Yep. Oh, we do have one. Oh, that's the one I typed in. So you shouldn't. I actually did just type that in, but that proves that it was working, I guess. I typed that to be a wrong one on purpose. I don't know what it actually was. I think it was a 102. There we go. So it looks like there's no invalid data or invalid values on the education. You can decide if there's anything missing. You can either do that by saying it's a 0, or if there's missing data. If you think it's missing data, you could probably go write a formula. Something like, I don't know, count if. Or count blank would probably be better. There we go, let's do that. Count if it's blank, that's easy. I didn't get all the numbers there. Let's go. There. So it says none of the cells in there are blank. So if that's our definition of missing data, then there's no missing data. And all the numbers are invalid or in a valid range. So for education, I think that's a pretty clear-cut thing, right? That's all they're asking for. There's no outliers, there's no missing data. Does that make sense on what we did for education? And you can just choose however you want to work on it. Because again, you can do counts, right? We just, You can go look for all the specific codes, right? 101, 102, 103, and then just go do counts, just like we did here for the blank, right? Go countative. I don't know, what do we do, 101? Give it a bigger range. There, so there's a real thing, right? So if we have 35 101s, and then we would just do that for all the codes. That's a different way you can do it, or you can do the red circle way, or you can do columns. Over here to the side, instead of doing a count, you could do the 1 or 0 thing that we'd done before, right? With the if. One, and if it's true, put a 1. If it's not, put a 0, something like that. And then you could drag it all the way up. You can see all of them. So here we do have a couple of 101s. They turned on. And we could do columns for all of it. You see, so there's 3 different ways I just showed that you could do this pretty easily. And it's up to you to pick what you prefer. Again, there's not a right or wrong way to do it. Okay. You guys have questions about that? Let's find one where we do have an issue. It's probably going to be over in maybe payments or income, maybe. I don't know. Let's go look. Payments or income. So probably that one. Seems like there's a little bit of a disconnect here. Which one is, let's try total family income. Total family. Okay. So the FTOT val, which is K. Okay, so it should be a numeric, 0 decimal places, 6-digit. So it's gonna be 6-digit, and if it's not entered, they're gonna default it to all 9s, it looks like. That's interesting. So what is, so it looks like it's derived from this other column. I'm not sure if that's included here. I don't see that other column here, so it might not be one that's here. Because I was looking at these numbers and I was thinking it's interesting that there's so many that are identical, right? Because if this is family income, I mean, everybody's going to have a different number. There shouldn't be so many similarities. But look like it's a formula from a different column, and I'm not sure what's going on in that column. So all we can stick to is it's got to be 6 digits or less. And if they don't know what it is, it's going to be all 9s. So with that in mind, these zeros are a little weird unless you don't have an income. Maybe that's what you mean if you're retired. I'm not sure. Let's go back and look what they say about that. Yeah, totally family income. CPS. It's interesting. Yeah, a little unclear on exactly what that means. So something like this, we again would do the same thing. We'd look for any number. So we'd make sure there's not anything more than 6 digits. So like, is there a 7-digit? Like, are you into the millions? So that would be out of bounds. Are you less than 0? So negative numbers would be out of bounds. And then the all nines is a special case. So we would have to do something with the all nines, like recode it so that we could actually do something different on that or count it. Otherwise, it doesn't look like there's much else going on here. So let's put in those rules really quick and see what we get. So we would say less than 0, because that's gonna be a negative number, or more than, that's our maximum. So again, just do a count. If, give it a range, give it a criteria, less than 0. Got to put that in quotes. I think I did it wrong. Yep. Give it a proper range. Okay, so there's no negative numbers. And then we'll just say if it's greater than 999,999. Okay, so there's no people who have, there's no negative numbers and there's nothing over the 999s. We might be curious to find out if there is any just 999s. Let's get rid of that. Looks like there's none of those either. So looks like all the data is fine. It's pretty boring. Let's go find a different one. I guess let's look at the instructions to pick one. Oh, and 2 variables of your choosing. Okay. I'm kind of curious about what the rules were for this one. EXP taught. Same thing. 6-digit number. So this one is how much they're paying for their health care. Or maybe that's this one. Let's see. Yeah, how much they're paying for their health care. And again, 6 digits. There's nothing special with the 999 this time. All right, so let's just go do the same thing. Let's call them Y. So now that we're dealing with numbers though, so this column Y is going to be the first time we can do something a little bit different. Let's copy these though, just to see. Just going to switch these to Y. Oh, it did it for us. That's nice. Make sure it did them all. Excel's pretty smart. It knew that I copied over to the Y column. Okay, so there's no weird data here. There's no over 1 million. There's no negative numbers. There's no 999s, which doesn't really mean anything in this case. But we can start to look for outliers here with these numbers, right? This is where things like the mean, the median, and the mode might start to make sense. And then we can start to see if we have any weird data. Okay, so it's the average. Mm. So interesting. So if you remember from our last assignments, the mode is the most common number that we see. It looks like by far the most common thing people are paying is 0. That's for their health insurance or health care per year, I guess. Whereas the average is 44.71, but the median is usually the one I would prefer in a case like this. If you remember medians, to get that number, it ordered all the numbers from smallest to biggest to put them in order. And then it just found the middle slot, right? So if there's 1,007 or 1,001 rows, it just went to slot like 500 or 501. And what was that number when they're all sorted? And so this is typically a really good idea for what is the middle value. So half the people should be paying more than this and half the people should be paying less than this. Some of the drawbacks with the mean is that this is including high and low numbers. And we can, I think in this case, we are getting some of these extreme numbers that are skewing things, right? So the average person should be paying around $850 a year. But with the average, we're seeing it's about 4,500, which is a pretty big number. And so we probably want to go see why, or what are these big numbers? And then maybe we want to exclude them because they're not representative of the average person. And again, if we do that, we would have to first identify what a big number would be. And then we would want to do, make note of that and whatever instructions we're doing. There's a few things you can do. You can do like quartiles or mid-hinge. I don't know if we even talk about that anywhere, but oops. Didn't take it. Let's do inclusive. And we just want Y. All Y. Nope. Okay. I haven't actually used this one before. I just know that quartiles is a good one. Okay. So it's the same. Which percentile do we want? Copy that for later. So this is going to get us a good look at our data. So here's our minimum. This is what's at our 25th percentile, our 50th percentile, or 75th percentile, and then what's our maximum. And we get to change those just by switching this right here. This is usually a good way to understand your data. And then this one is a 4. Okay, so here's some basic statistics of how our numbers are breaking down for our column Y, right? Which is again how much someone spends on healthcare. And I'm trying to figure out how come the average is about 850 or the median, but our average is about 4,500. That's a massive difference, right? That's like a 5-fold change. And so we can start to look here. These are the quartiles. So this means, again, to get the quartile, it orders the data and it figures out what's the first 25% of the data look like, the second 25, what's the average of that, and then what's the last average, the 30, the 75th percentile, and then what's the max number. And so you can see someone is paying $153,000 per year, which is wildly out of whack with even 4,500, but it should be closer to 800. So we definitely have a case for removing this 153,000 because that's just obscene. And then we'd have to go look and see maybe there's some in the 75th percentiles. So really, we just want to go see if there's anything really over like 3,500 or 4,000. It's kind of like, looks like the threshold for what we would be looking at, right? So between 3,500 and 4,500, it would be our max numbers we would be interested in. And so anything over that, we could have a justification for removing from our data. And then we would rerun our analysis and on, that column. And specifically, we can go definitely pull out this 153. So So again, you would have to make notes of this in whatever analysis you're doing or whatever paper you're writing. You know, there's obviously something going on. Why is this person paying, you know, like 100 times what anybody else is? We don't know, but we would just exclude that data, right? Here's another one, right? 88,000. That's very obscene. 132,000. Geez. So there's quite a few here. And so you could probably make the case, just go do a blanket calculation here and say anything over, I don't know, 4,500 or 5,000, whatever you decide, we're just going to delete because they aren't really representative of, you know, the average patient, right? The average patient is somewhere between $132 and I don't know, like $4,000. So anything over that, we would just delete. Does that make sense?
Kind of.
I kind of just rambled there. So hopefully you guys are asking questions.
Dr. Hodge, question.
Yeah.
So when we're going to delete those rows that contain, let's say, 0 or more than,
Uh-huh.
I don't know, whatever, do we just delete the row? That's it?
Yeah. So that's a good question. There's a couple of ways you can do that. And again, it just depends on what you want to do with the data. A good rule of thumb is to keep this whole tab, this whole first sheet sort of unchanged, keep it exactly how it's going to be. So you have a backup of your data. And then you would copy all this data into a second sheet. And that is the sheet that you would start messing around with. And that way you have a backup to go to. So if I do that, paste it in here. So now I've got some data I can mess around with. And if I get into an issue, I can always go back to the original data that hasn't been changed. And so say, for example, I wanted to delete these zeros right here on this edge, on this FTO val, right? You can just start deleting those pretty easily. And now they're gone. So yeah, you can definitely do that. And maybe you want different sheets, right? So here's how I'm messing with the data for the K column. Here's how I'm going to mess with the data for the Y column, and they're maybe their own separate tabs. Yeah, it's whatever you want to do. As long as you have the original data to go back to, you should be fine. At least that's what I would do.
And making changes on the copies on sheet 2 and sheet 3 should not mess up sheet 1, which is the original one, right?
Right. Yeah. So you can see I deleted a few of those rows. And then if I go back to the original one there, oops, if I go to the top, we'll see them. So I deleted these 3 rows on that other sheet, but they're still here on the main sheet because they're just copies. Yeah. Yeah. So it doesn't mess with it.
Thank you.
Uh-huh. Okay. So I'm looking here at question number 2. So obviously what we just did, you would just repeat for all of these other variables or columns that they're asking about. We just did a couple of them, but there's looks like 5 or 6 of them there. But similar steps. And then all it's really looking for is, you know, like explain what you found and what you did. So nothing like too groundbreaking. Just think about what are your justifications for doing what you're doing and how did you do it? And again, there's no real wrong answer as long as you're addressing the specific issues. Because maybe some columns don't have any missing data and you're just say, I don't see anything wrong with this. Or you can do what I just did on that, whatever column Y was, I forgot, like healthcare totals. You can say, oh yeah, there's some real weird numbers. We don't want to include anything over 4,500 because that was our 75th percentile or whatever. As long as you just justify what you're doing, that's fine. So then looking at here at number 2, oh yeah, we just talked about this. So this one is saying they want education put into dummy variables with 1s and 0s. And we talked about that briefly. They even started to do it. Right, so we could insert a bunch of columns. So the reason here, it just depends on what you want to do with the data. But if you want to do something like a linear regression, linear regression needs a certain type of data to work. It needs data that has like a true 0, number one, and data that has levels to it, like meaningful levels. Like what I mean is like ordinal data. Ordinal data says a 2 is greater than a 1, and that's objective, right? So if you see a 2, that's something more significant than a 1. But what we have here in education is not necessarily ordinal data, because a 601 doesn't necessarily mean it's better than a 301. And if it is better, it doesn't mean it's twice as better, which is what this would imply, right? I don't even know what a 301 and a 601 are. Let's go look. A 301 is a high school graduate and a 601 is a master's degree. So maybe it looks like they are applied in order, right? But it doesn't mean that it's twice as good, right? Is a ninth grader twice as good as an eighth grader? Not likely. And even if that were true, we've already broken the whole pattern by putting the unknowns down here in the 900 levels, right? This would mean that 999 is the best education you can get, when in fact, we don't even know what their education is, right? Or we're saying that 604 means an other degree or no degree, a 996. That doesn't mean it's 9 times better than, I don't know, or 3 times better than a high school diploma, right? So there's a lot of assumptions that have to be made to do these linear regressions. And this data is not in that type of format, an ordinal format that we can make use of. So we have to recode that data if we want to use it in any of our calculations. And that's what we're talking about here on number 2. And so to do that, we'd have to do just what we had started to do before. You're going to have to do some columns. And I don't know if you do, I don't know if you have to do it for all of them. I'd have to read the whole assignment, or if there's just a specific few education levels they're interested in. But we could say, right, here's what the 101, the 102, the 103, or whatever, right? You're saying this is high school, GED, university. I don't know what the numbers are. I'm just making it up. But you're gonna have to convert this column E into something useful, like a 0 or a 1. 0 or 1s are the type of number we need, and they do make sense for what we're trying to do. Because a 0 means there is no high school diploma. A 1 means that there is, and a 1 is better than a 0. So those two conditions are being met. And those are the kind of data we need for linear regressions and other calculations. Whereas, again, this sort of data doesn't mean what we need. And we could use this data to run linear regressions. But again, those assumptions are being made and they're wrong. And it's going to produce results that are contrary or don't make sense. It's not going to complain about it because it doesn't know the data you're using is good or bad. It just runs the data. And we as humans know, or need to know, that we need to have ordinal type data, and it'll make our results accurate. Find that again. So high school or 101, I don't know. Let's see. High school graduate, 301. Let's just do 301. All right, so we're going to say if this equal to 301, and turn it on, otherwise turn it off. And then we would just do that for the whole column. All right, so now we just got the 0s and 1s for everything. And now we do that for all of them, right? So we just did the 301, we'd have to do it for the other 25 or 30 of them. And now we have actual ordinal data that would help us do our calculations for linear regressions. And that's what we're talking about doing here for number 2. And it's similar to what we've had to do in, I think, one of the past assignments, if I'm not mistaken. Okay, yeah, I should have read further. So we just want a few of them, right? No degree, GED or diploma. So that's high school or GED. So it's going to group a couple. And then a bachelor's degree, and then a master's or doctorate, and then all others. So it looks like there's just 5 categories. 1, 2, 3, 4, 5. Yep, 5 categories. It says it's going to make it even more complicated because we have, so there's just 5 different categories that the assignment's asking for. But we have a lot of choices here. How are we going to break these up into those 5 categories? And they're, again, it's going to be some subjective answers here. So let's try our best and see what we can come up with. So no degree. Let's go find all the codes that equal no degree. I'm assuming this one is, I don't know what NIU means. We can assume anything from here up is no degree, right? Because they're still in grade school, high school, 12th grade, they haven't graduated. All of that is no degree. Let's go down further. So now we could say codes, these specific codes are one thing. And then what's the next one? GED or diploma. So that's GED or diploma. I assume that would also be a GED or diploma. I assume this would also be a GED or diploma. Let's see. Okay, then we want bachelor's degree. So now we have the weird thing. We have some associate's level stuff, right? Is that going to be under GED or diploma, or is that going to be under bachelor's, or is it going to not be counted? Right, so here's bachelor's. Hang on, I forgot already. Yeah, bachelor's degree. That's just one whole category. So bachelor's, that's it. The other one is master's or doctorate. Master's or doctorate. Master's or doctorate. Master's. Master's. Okay. So here's something saying they have a degree. How are we going to quantify that? I don't know. I don't know what that means. They do have a degree, so it's not a no degree. We assume it's higher than a GED or diploma because they do have a college degree. We don't know if it's an associate's or a bachelor's or a master's. So how are we going to quantify that? Or do we want to just exclude it? That's also a choice, right? Are we just going to exclude those? Are we going to exclude these? I don't know. This is where it comes to you. How do you, what's the problem you're trying to solve? Where does this data sort of fit in with what you're doing? This is definitely a no degree. So I would say we exclude anything that doesn't specifically fit in what we're trying to do. But again, that's how you choose to answer it. So now we're going to go do a little bit different right here, right? So we're going to say, we just got like 5 columns we need, which is a little bit easier. Just start over here. So we got no degree. Was it degree or diploma? And it was, I think, a bachelor's. Then it was a master's or doctorate. 1, 2, 3, 4. Was that it? Yeah, and then the rest were excluded. Oops. Okay. We can start with the bachelor's. That's easiest. So let's code 500. It's just one. Count it if this is equal to code 500. Oops. A little too excited. A 1 if it is, a 0 if it's not. What did I do? My gosh, how did I already mess this up? That's hilarious. Okay, let's try this again. Count. No, I want to count if. Count if. Range. Criteria. Okay. Okay, so here's all the bachelors, right? So these are the 500s that turned to 1. And then we're gonna have to do that for these other ones. They get a little bit more complicated because we got to do the count ifs, which are a bit of a pain. Criteria range. So it's gonna be the same thing, right? So what did we decide? So we're doing no degree. Oof. So 0 or 100. Okay. So, oops. There. Um, and then the second one. We'll just do 2 for now. So we would replicate, or sorry, we would continue this on for all of them. For 101, 102. I think this one's the longest one, 103. I think you get the idea. 104. There. If 5, 6, 7, 8, 9. Five, 6, 7, 8, 9. Then I think it started at 200. Yeah. 1, 2, 3, 4. Okay, 1, 2, 3, 4. Getting there. Uh, 201. 2. Okay, so I don't think that's even all of them still. Let me make sure. We're doing the ND. Okay, and then 996 is the last one. 996. Okay, so we got our formula here in this first cell. If we just double click this right here, it'll fill all the rest out. So anything here that's a 1 means there's no degree. Scroll down till we can find one. I feel like we should see one. Maybe that's good. Maybe everybody has a degree. No, because here's a 108, right? And 108 is, so obviously I got a problem with my formula. But you get the idea of what we're trying to do. That's so frustrating. So that's obviously not working.
Aren't you maybe missing the 1 on your formula?
Maybe.
Is that the problem?
I don't think, well, I'm just looking at this other column, this column H that I did for the bachelor's degree, and I don't have the 1 or 0 on that one, and it's working. So I don't know if I specifically need it. I think it's the way I'm putting them together. I don't know. I'll fix this on my own and then I'll post it with the video instead of taking up all the class time. But that's the idea, right? So for part 2, we would need to codify these. And so we did a couple of them. We did column H properly. This one, we're on the right path. I obviously did something wrong with how I wrote it. We'll figure it out. I'll post it. Then you got to do the other ones, right? For the degrees, the master's and doctorate. And so now they're codified into actual data, right? It's gonna be these 4 columns that we can use for doing regressions and stuff. And then yeah, so when you answer that question, it just says decide what your reference group is. Okay. Yeah, and then the next part is going to actually be running regression, and that's just like we did on previous assignments. Looks like this one has a specific formula they're looking to use. So when you do the regression, do it for each of these columns specifically, and that will give you the formula. And then you can just talk about which ones are significant, which we did. Predict. Okay, yeah. So the whole point of regression, and we talked about this a little bit in the exam and a little bit in the last assignment, is to be able to predict something, right? So when we do this linear regression, we plot a line, right, between 2 variables. And the line's going to have some sort of direction, up, down, or horizontal. And it's going to have some sort of rate to which it's increasing or decreasing. And then the idea is to use the rate of the slope of that line to predict something into the future that hasn't happened yet. And so the idea here is using the regression that you do on number 2. What would you expect out-of-pocket expenditures to be for families that are making 10,000 or for families that are making 50,000? And so that's the whole idea here. That's the whole reason we do linear regression, is to do some prediction here. Interesting. Yeah. So it's talking about running those with both the clean data and the dirty data, meaning the data you haven't cleaned up. So figure out what the linear regression, what's the answer for 10,000 and 50,000 with the clean data, and then what is the answer for the 10,000 and 50,000 with the data where you didn't delete or change anything, and then just see what they are. And that would help you to understand. The whole point is to understand why do we actually clean up the data, and you're going to see you're going to get very different results. And everybody in the class will probably get different results because it's how you chose to personally clean the data. And so it's not going to necessarily be, is there a right or wrong answer? It's making sure that the Excel spreadsheet that you submit is doing the steps that are asked for. You justify what you're doing, and then you sort of come up with your prediction. And then as long as you're following those steps, you should have no problem getting the credit for it. It's probably going to take a while. You just saw we tried to do one of those and it took a while, and we've already been on here for like an hour. So it's going to take a while. So I would get started on this sooner than later. And I think we're meeting next week. Make sure. So you guys can come with the work you've done, and we can look at it as a class here.
Yeah, because it's not due till the 18th. Yeah.
Yeah.
Just
Yeah. So we'll meet again on the 14th, and so that's before the assignment is due. And if anybody's interested, they can bring their work and we can talk about it as a group.
No, it's due the 11th.
I thought the assignment was due April 11th. Yeah.
Yeah, it's the 11th.
All right, let's see.
I was thinking about our mock trials. But yeah, it's the 11th.
Yeah, it is. You're right. So I guess in that case, then just email me specifically if you get hung up on something, and I'll do my best to answer it quickly. But again, don't fret about getting the right or wrong answer. It's just following the steps and justifying what you're doing and actually doing the steps more than getting the exact dollar numbers right. And then once it's due, I will post the work that I did, and we can compare the next time we meet. So anyways, we're over time. I hope this is helpful. If we didn't cover your topic, yeah, just shoot me an email.
You're gonna upload it like you did the other ones, right? So
This
that we
video?
can go back and like
Yeah.
watch it slowly.
Yeah, correct. I will do that.
Okay, perfect. Sounds good.
All right. Have a good
Well,
day.
thank you so much.
Mhm.
Thank you.
Bye.